Okay, my calculus people. Derivative of an inverse function. It starts off kind of confusing, but it's actually not that bad at all. Okay, and you'll see this when we get going. But just to start with, let's derive. We're going to derive the formula because it's a pretty easy formula once we see it. So this notation, right, this -1, this is our inverse notation, right? So inverse operations or inverse functions are ones that, quote unquote, undo each other, like division and multiplication, or square rooting and squaring, right? Things that undo each other. So if I have f inverse of f, what happens is those undo each other and you get x as your answer. Okay? So if you take an inverse and then you compose it with its function, right? This is composition. Then you get x as your answer, right? Not 1 or 0, you always get x. So from here, what if we were to take the derivative of this function, right? Of this equation, right? And that's what's happening right here. The derivative of the function with its inverse equals x, right? So we're doing this all together now. So this looks like a chain rule derivative, right? Chain rule derivative. So we do the chain rule by taking the derivative of the outside function, f prime of f inverse of x times the derivative of our inside. Okay, so you might not like the notation here, but the inside is f inverse of x prime, right? We put the prime notation on the outside of your parentheses here because we're multiplying the inverse derivative times the derivative of the function, right? So f prime of f inverse of x times f inverse of x prime equals, what's the derivative of x? Equals 1, right? The derivative of x equals 1. So all of this stuff comes from the chain rule derivative of a composition of functions. Okay, so no, you're not going to be tested on that. It's just nice to know where it comes from. So if we were going to solve this equation for this, right? Since we're talking about the derivative of the inverse, that's this part of your equation, right? Here's your derivative part, the prime. Here's the inverse part. How do we get rid of the left part of our multiplication? We undo multiplication by dividing. So in essence, we're going to divide both sides by f prime of f inverse. Divide by this stuff. And this is our formula. Right, here we have the derivative of f prime, which you will also see written as f inverse of x prime. Okay, so you're going to see it both ways with the derivative notation out front or with the prime notation after. Equals, well, we're dividing 1 by all this stuff. So 1 is in the numerator. And then we have f derivative of f inverse of x. Okay, so this is our formula that we are working with, right? So the two things are the derivative notation and then your prime notation. These two things mean the exact same. So you're going to see it written here in the purple, and you can see it written with the derivative notation. It's the derivative of the inverse of a point, right? And this is the derivative of an inverse. So what two things do we need to do? Because we need to do two things. Number one, we need to calculate the inverse at a point. Okay, what is the inverse of your function, right? So the inverse is where you switch your x and your y. So this, when we're given it in practice, this is going to be a y value, right? Because for the inverse, you switch your x and your y. So that's going to become a y value that you're given, and you're going to find the x value that goes along with it, and then we're going to find the derivative at that point. And then, of course, we reciprocate. So our last step is going to be reciprocate. Okay, so there's 3 things we're going to do. So let's just go ahead and do it, shall we? The answer is yes. So example 1. Here is your function, and I want to find the inverse, the derivative of the inverse function when we have 6 as your value. Okay, so once again, the inverse, the derivative of the inverse of 6. So if this is 6, is that an x value or a y value? That's a y value, right? Because it's the inverse, which means we know that y equals 6. For some value of x, we know that 6 is going to equal 4 times something cubed plus 2 times something. Okay? So usually if we were going to find an inverse function, we would switch the x and the y's, and we would solve for y. Well, this one's pretty dang tricky to solve that for y, right? 4y cubed plus 2x equals 6, right? Maybe not so much. So let's just think about this in terms of thinking. Let's just guess and check. I need to do 4 times some number cubed plus 2 times that same number, and my answer is 6. So what if x was 0? What does that give us? 4 times, well, that's 0. That's not any good, right? 0 is 0. What if x equals 1? Then that's 4 times 1 cubed, which is 1, plus 2 times 1. Oh, that works pretty nicely. So x equals 1, right? So we use guess and check. We guessed some, hopefully small values, because I'm cubing something and adding it, and I'm getting 6. So I'm guessing if x equals 1, then yes, that doesn't. What about negative 1? Does it work if it's negative 1? No, because then that's negative 6, right? So this is my x value. That's perfect. So that's your first part, is we just found f inverse of 6. Actually, we just found this part, right? We just found that part of your equation, f inverse at 6 is 1. So now we have to figure out what is f prime at 1, right? So let's look back at what we're doing. We are using our equation 1 over f prime of f inverse of 6, okay? We just decided that f inverse of 6 was the number 1, right? So that's 1. So now we're going to find f prime at 1, right? That's the next thing that we do in solving this little equation here, f prime at 1. So let's take the derivative. What is the derivative of 4x cubed plus 2x? Right? Hopefully that's not a problem for you taking the derivative of this polynomial. 12x squared plus 2. And now when I plug in 1, what is my derivative at 1? 12 times 1 plus 2 is 14. Okay? So this is my denominator of my answer. So I can write the answer as 1 over 14. And that is your complete answer. Okay, here we have, we don't have an equation or anything. We're just given a bunch of values. F of 2 is 5. F prime at 2 is 13. F prime of 5 is 8. And I want to know what is F inverse of 5 prime. Okay, so let's write this down. F inverse of 5 prime, the derivative is 1 over f prime of f inverse of 5. Okay, so this time we're just going to use our equation and just go horizontally. 1 over f prime of. So let's see, from our given information, what is f prime at, or f inverse of 5? That means when my y value is 5, my x value is 2. So I'm really looking for what is f prime at 2. F prime at 2 is 13, so my answer is 1 over 13. Okay, so here we have x cubed plus x, and I want to find f inverse of 10's derivative, right? Derivative when f is 10. So f inverse of 10 prime equals 1 over f prime f inverse at 10. Okay, so remember with f inverse, this is a y value. So I want to know when my x cubed plus x will equal 10. What number cubed plus that same number gives me 10? And I'm guessing it's going to be 2, right? 2 cubed plus 2, well 2 cubed is 8. 8 plus 2 is 10. So this whole entire thing becomes a 2. So f prime at 2 under 1. So in order to now evaluate, I have to take the derivative of x cubed plus 1 and plug in 2. Okay, so let's do that over here. X cubed is 3x squared plus 1. And I'm plugging in a 2. And that's 4. 4 times 3 is 12. 12 plus 1 is 13. So my answer is 1 over 13. Completely coincidental that that was also the answer for the one before this. Right? Completely coincidental. So let's check it out with a table. Now we don't have to take a derivative. The values are given to us. So we have an f, right? This is our y values here, and this is your derivative there. Okay, so when we start, remember this is a y value. So we're going to find what is f inverse at -1. So that means when f is -1, my x value is 3. So I'm really looking for what is the derivative at 3, which means I come up here and I find 3 and I take the derivative down here and I get an answer of 1. So this answer is equal to 1. Okay, so it's 2 steps. Almost always we have 2 steps here. So this is your y value when f is 3, x is 5. So f inverse of 3 equals 5. So then what is, oh wait, I wasn't done, was I? No, I apologize. Well, okay, the answer is still the same. But f inverse -1 prime is 1 over this, right? So 1 over 1, of course, is still 1. But it's not going to be for my next one, okay? So I'm looking for what is f prime of 5. When f prime is 5, y is 1/2. So then f inverse of 3 prime is the reciprocal of 1/2, which is 2. So my final answer is 2. Because it's 1 over f prime f inverse of x. So 1 over 1/2 is 2. Okay, so the last thing we do is we reciprocate it. Let's see, one more of these types of problems. When the y value is 5, my x value is 7. So f inverse of 5 equals 7. So then what's f prime at 7? The answer is 2. So then my final answer, f inverse of 5 prime equals 1/2, the reciprocal of 2. Okay, so don't forget to reciprocate like I almost did on these problems. Okay, let's end with a couple trig problems. So I'm looking for the derivative of the inverse of 1/2. Okay, so I want to figure out when is sine 1/2, right? That's what I'm finding. This is my y value, right? So it goes here. When is sine 1/2? At what angle is sine 1/2? That happens at pi over 6. Okay, so we're figuring out when is the sine 1/2, and that happens at pi over 6. So now I want to find the derivative at pi over 6. Okay, so what's the derivative of sine? Cosine. So what is the cosine at pi over 6? Well, that is root 3 over 2. Because if the sine is 1/2, then the cosine has to be root 3 over 2. So then my answer is 1 over root 3 over 2. And we never leave it as 1 divided by a fraction. So what's the reciprocal of root 3 over 2? 2 over root 3. Now that is a 100% correct answer, but you probably won't see it like that on a multiple choice portion. It would probably be rationalized, means you move your radical to the top and divide by the normal number. So the answer for the derivative of the inverse at 1/2 is 2 roots of 3 over 3. Okay, one last trig problem, the tangent, and I want to find the derivative of the inverse at 1. So first we put 1 in for the y value, so we put 1 in right here. 1 equals the tangent of x. Okay, so at what angle is the tangent going to be positive 1? That happens at pi over 4. Okay, so that happens at pi over 4. That's the angle on your interval, right? So we have negative 90 to positive 90. 45 degrees is in there. That's the only place in that interval where tangent is positive 1. So then we want to find what is g prime of pi over 4. So what's the derivative of tan? Secant squared at pi over 4. Okay, so what is the secant at pi over 4? The secant is the reciprocal of the cosine. The cosine at pi over 4 is root 2 over 2. Hopefully you know that one. So if we reciprocate root 2 over 2, that becomes 2 over root 2, which when we rationalize, 2 roots of 2 over 2 just becomes root 2. So the secant at pi over 4 is root 2. And when I square that, I get the normal number 2. So I'm almost done, because my last step is always to reciprocate, so my final answer is 1/2. So, to wrap up, it doesn't matter how you see it, but the inverse of a derivative, or the derivative of an inverse, is 1 over the derivative of the inverse of your function. Just memorize that formula.